So when we talk about relational database management systems, right, we will have a database. That database will have multiple tables. This we understood till now, right?
Yes.
So now to make sure, right, like the database remains constant when multiple people are using it, we need to make sure the database is same for all of them at any given point of time, right? So for that, there are few properties that are already defined, and we call them ACID properties, ACID. Okay, so this is very common term, and it will be asked in interviews like, could you please explain what is ACID properties in a database, right? So we will discuss this one by one. So the first property is atomicity, which is the A of the acid, right? So atomicity makes sure like all the transactions that is happening on a database or on a table, either it is going to complete or it will not happen at all, right? Like the bank example that I gave you. You made a transaction of 50 rupees from ATM, right? So now there can be two scenarios. Either the money will come out or the money will not come out, right? You will get a message like there is no money in your account. It will never happen in ATM that you withdraw a money and it will not change the balance of your account. Did you ever see that happening, that you withdrew some money from your ATM machine and it did not get reflected in your bank balance? Was there any such scenario?
No, not like that. However, like the amount got deducted, however, we have not received the money. That can't happen.
That happened?
Yeah, sometime happened. It did the money got stuck into the ATM at that time. Then that time
Okay,
we need to raise it.
then that is the opposite of atomicity. So
Yeah.
in database, we need to make sure if we do any transaction, either it will complete or it will never happen at all. So in this example that you gave, that amount got deducted and money did not come out, it's an incomplete transaction, right? So
Correct.
ideally it should not update a database like your money got deducted like that, right? So that is atomicity. So only two states, either it's completed or it did not happen at all. So as simple as that, right? And then consistency. So the database must be consistent before and after the transaction, right? If before transaction you had 100 rupees in your account, after transaction you should have 50 rupees as balance, and your bank statement should show that you withdrew 50 rupees, right? Then you have a balance. You had 100, balance is 50, you withdrew 50, right? That is consistency. Like you made some transaction, money got debited, you got the amount, and your database is now reflecting the correct amount, that you withdraw 50 rupees, you have 50 rupees as balance, right? That is consistency. Clear on this?
Yes.
Now next thing is isolation, right? So isolation means multiple transactions can occur independently without any interference. And let's take the same bank example, right? So your father is depositing 200 rupees in your account. Okay, you had 100 rupees balance. Your father went to a bank, any branch of the bank, and he deposited 100 rupees in your account. At the same time, you went to a ATM and you withdrew 50 rupees, right? So there are two transactions happening now in your bank account. Your dad is depositing 100 rupees, you withdraw 50 rupees, right? What should be the balance after the transaction? It should be 150 rupees, right?
Correct.
So that is like isolation. So even though there are two transactions happening on your bank account, but at the end it should show 150 rupees. That is the meaning of isolation, right? So people can make any transactions in any of the table multiple times, or multiple users can make the transactions at the same time, but that should not change anything in the database. It should reflect all the changes. That is isolation, right? Clear on isolation?
Yes.
Yes. So the last point is durability, right? And this is the example that you gave, right? Like you balance got deducted, money, you did not get the money, that is a system failure, right? So that should not happen. So it should be durable. Means if you are making a transaction, you should get the money, and if you don't get the money, there should be no changes in your database, right? So basically, if anything fails, there should not be any changes or any damage to the database. That is what is meant by durability, right? So all clear on these 4 properties?
Yes, just there is one like regarding the isolation. In the isolation, you just mentioned the multiple transactions occur independently without interference. That means once, suppose we have given the example, one side it has been deposited, and another side it has been credited. So you mean to say these are the multiple transactions
Right,
should occur.
right. So when you see this, your bank statement, right, it will show you like your dad deposited 100 rupees, you withdraw 50 rupees, your balance is 150 rupees. Agreed? So
Yes.
basically it captured all the transactions that happened in your account, right?
Okay.
Yeah. So that is what is